Yesterday we got all the way up to the x-intercepts, correct? So here's what happens. When you're finding the x-intercepts, you set the function equal to 0. 0 equals negative 1/4 x squared minus 6x plus 3. Okay? Now, that's the equation we would like to solve, which notice that we started our work in first semester with solving equations. So I'll give you a little trick here. I don't like the fraction. So I would like to multiply through by something to get rid of the fraction. Not just 4, but negative 4. And 0 times negative 4 is 0. And negative 1/4 times negative 4 is 1, so I have x squared. What's the rest going to be? Plus 24x minus 12. So that definitely does not factor. Everybody agreed? So what I need to do is I need to solve this using the quadratic formula. Who remembers what the quadratic formula is?
B plus or minus the square root of b squared minus 4 times a times c.
Excellent.
All divided by 2 over all over 2.
So, just to be clear, if you forget anything that we covered yesterday, including the quadratic formula, I have a nice chart here. Everything in standard form for parabolas sits right over on that right-hand side, which includes the quadratic formula at the bottom.
Thank you.
Everybody see that? It's on the next page.
Whoa.
Now, let's use the quadratic formula.
Yeah, but 24.
X is equal to negative b, negative 24, plus or minus the square root of, what is 24 squared? 576, good, I'm glad you memorized that. Minus 4 times
A, which is 1.
Times
C, negative 12.
divided by dos, which is Spanish for 2.
C.
Kick him out of class. All right. So this is called the discriminant. The discriminant is an extremely important part. The discriminant, we need to know if it's positive or negative. Is it going to be 576 plus or is it going to be 576 minus? It'll be plus. It'll be 576 plus 48. Somebody tell me what that is?
No. 621? Nope, it's not actually.
Is it 624? Jack? Okay, thank you. All right, so 624 over 2. So we need to simplify something, and if you end up with the square root of 624, like that's a tough one, right? And you kind of just have to guess at some point. But 624, and we want to see if it's divisible by a perfect square. What do you want to guess? Let's try 4. Yep, 4 worked. 624, let's try it 16. And it turns out that if you divide by 16, you get 39. Sweet. So everybody agree 4 roots of 39? So here we have negative 24 plus or minus 4 roots of 39 divided by 2. Now, at this point, you need to simplify it as well. So is everything divisible by 2? Yeah, so you're going to have negative 12 plus or minus 2 roots of 39. Now, yesterday we started to make a graph, didn't we?
Yeah.
And our point, our vertex was way up there, wasn't it?
Yep.
And we were headed on down. Okay, we know it's upside down. It's tough to plot that, isn't it? So when you are working with standard form parabolas and you're asked to find the x-intercepts, I will have 2 expectations. Number 1, you provide simplest radical form. Number 2, you write it as a decimal. So I'll show you how we do that. We just take out our calculator. Oh, you're back. Yay. And we're going to go negative 12 plus the... Thank you. Negative 12 plus 2 roots of 39. So we'll go 2 second root of 39. And when you do that, you can tell you get 0.49. Is that something you can plot? Sure. Can I show you a little trick with your calculator? I now want to type in the same thing, right? I just want subtraction, right? If you go second, enter, which is entry, it brings up exactly what you previously typed in. You can press subtraction. And that can help, especially when we get longer expressions later on. Press enter, and we get negative 24.49. So when you plot 0.49, and when you plot negative 24.49, does those seem to fit with your graph? Does it seem to make sense with the other points that you have? It should. And you're able to then draw that graph like we had yesterday. So what I want you to do at this point is we are going to pause. There's some people who have, half their assignment already done. There's some people who haven't started yet. That's okay. I have the answer key all ready to go for this. It's also posted online. And I'd like you to take about 12 minutes in class, 15 minutes in class, and I'd like you to work on parabolas in standard form. So go ahead and let's take some time to work on that before we talk about the next piece that we'll practice tomorrow.
Okay, now I'm forgetting everything that I heard.
Okay, we move on to this piece. Vertex form. What is vertex form? Well, here's what it is. So standard form is y equals ax squared plus bx plus c. And we know that full well, correct? True or false, that's review. For this next test, that is the only thing that's review. Everything for the next 2.5 weeks will be new. Which is what makes this next test challenging. Everybody got it? So, when we start covering new pieces, it's harder to remember. I will go slow, make sure we're good. Here's the new part, vertex form. Y is equal to A times x minus h, quantity squared plus k. Now, some of you are like, I've seen that before. Like, I remember that. That's review, Mr. Gens. But not in the way that we're going to work with it. Okay? The nice thing is, in this situation, if you want to find the vertex, you take negative b divided by 2a. We're used to that, right? But in this situation, the vertex is just hk. It's very simple. Like, you could just look at it and see the vertex. For example, if I had y is equal to, say, x minus 3 quantity squared plus 1, you know that the vertex is just 3, 1. See how you just look at it and know it? That's why we like that form. So we're going to turn something that's in standard form into vertex form. We're going to do a couple things that will make you feel uncomfortable. Please just embrace it and trust that this is going to work out. F of x is equal to x squared minus 6x plus 1. What I want to do is I notice that in vertex form there is a completed square. Notice the completed square? Have you completed the square before? Yes, and we're going to do it again today. So, I just put the 1 off to the side. This is the same as that, is it not? Yeah, so let's figure out what number you add to complete the square. Does anybody know? Take this, divide by 2, and then square it to get good. Okay, here's the part that you're going to be frustrated with. So I'll show you, and just trust. You're going to be okay with this eventually. So if you add 9 to that side, you should. Okay? But the fact is there's nowhere to add the 9, right? Like eventually you would take that plus 9, and what would you do with it to get it over here? You would subtract. So instead of adding 9 to the other side, I will subtract 9 from the same side. Somebody tell me, if I have a plus 9 and a minus 9, what's the net change? What's the net change? 0, right? And so we have equality. Everybody see that? I know you may not like that, but that is the way in which we will complete the square more often. So we will do other things moving on in this class where we complete the square that way. Let's see what happens. We get f of x is equal to x minus 3 quantity squared Minus 8. So somebody tell me, what is the vertex? Positive 3, negative 8. Could you then sketch the graph? Yes. And what I will ask you to do for this assignment for vertex form, you're not going to find the x-intercepts. You're not going to find the y-intercept. You're not going to find the axis symmetry. You're just going to put it into the form, identify the vertex, and just quick sketch a graph up or down. Yes? So, I think I can answer your question here. Remember, is the minus 3 on the inside or outside? So that affects it horizontally. So it moves the center from 0 over to positive 3, and it's opposite of what we think. The minus 8 is on the outside. That's a vertical shift, and it's exactly what we think. It's a minus 8. Better? Excellent. Flip it. Here we go. You will in your assignment. We're going to try to save time now because we're going to be up against the clock here. What's different about letter B? It's flip-flop. Let's change it. So we've got f of x is equal to negative x squared plus 4x. Are you okay with that?
Nope.
We do have a... Right. We have a slight problem. Anybody know what I'm going to do with the negative? I'm going to factor it out. Yeah, so I have f of x is equal to a negative, parentheses, and then what do I have left? X squared minus 4x. Excellent work. So, I need to complete the square. What number completes the square? Everybody go with 4?
That means you put minus 4 where C used to be, or C would be it.
I'm sorry to say, but we do not subtract 4.
What do we do with it?
Everybody pause. I did not just add 4.
Who subtracted?
See the negative here?
Right.
So this 4 does not have a value of positive 4. It has a value of negative 4. So I've actually subtracted 4, so therefore I should add 4. See that? Yep, got to be careful there. So now this factors f of x equals negative, and then x minus 2 quantity squared plus 4. You can see why I want you to be working on this in class tomorrow, because you can see that it's easy to maybe make a mistake and wonder, and I want to be there with you and help you, okay?
So that was a vertex negative 2, 4?
Close. The vertex is positive 4.
Oh, so wait. The negative just what is it? The negative just
The negative only creates a vertical flip.
Yeah. I understand that.
Doesn't change the location of the vertex. We all okay? So yeah, so you would plot 2, 4, so over 2 and up 4. So plot that vertex, and then you know it goes direct down. That's all I'm looking for. Just a very quick sketch. Everybody okay with that? All right, last example. You're doing a great job, okay? Do you think that this one is easier or more difficult? Thank you. All right, so I gotta deal with this 2. Here's what I'm gonna do, and again, we're gonna just take it one step further. You're gonna be a little upset at me again. I'm gonna factor out that 2. If I factor out the 2, what do you think I'm left with? X squared, good. And if I factor 2 out of negative 3x, anybody? Very good, minus 3 over 2x. Okay, so here's the problem. If I factor a 2 out of the negative 1, it would be sitting right here, wouldn't it? Isn't that where I want to complete the square? So let's not factor a 2 out of the negative 1. Let's just put the minus 1 there. Now, some people, when they do that, they're like, it seems like we're just making stuff up now. So here's what you do when you feel like you're making stuff up. You take that 2 and you distribute it back through. What's 2 times x squared? Well, that's what I have. What's 2 times 3 halves? Yeah, it's the negative 3. That's what I have, right? And then I have a minus 1. So we're not changing anything. And I know it looks different, but we need to get used to this so you guys will do just fine. All right, how do I find the number to complete the square? I take negative 3 halves and I divide it by 2. Oh my gosh, that doesn't look fun, does it? Instead of dividing by 2, I could multiply by a half. Anybody tell me what negative 3 halves times a half is?
Negative 3 halves.
Negative 3 fourths. Great, so I get negative 3 fourths. Then what do you do with it? You square it to get, good, 9/16. All right. So, when we see the 9/16, I did not just add 9/16. What's the true value of that 9/16? 18/16, which is 9/8. So you can see that what I really added there wasn't 9/16, but 9/8. So if I added 9/8, then I should subtract 9/8. Excellent work. I have 2 times. What is this factor to? X minus 3/4. Good. So what Ella sees here is that this number, it's always the square root of that. Okay? So that's squared. And then minus 1, so that's like 8/8, right? So what's negative 8/8 and negative 9/8? Negative 17/8. Yep. So what's the vertex then?
3 4 and negative 17/8.
Excellent job. Good work. So the 2 creates a vertical stretch that's not part of the vertex. Excellent. Thank you. Good. Nice job, Trey. Okay. So there's 1 minute left, and what I just want, part of teachers' work and part of my work when I got back and got my master's is that you study like brain research. And I will tell you that the fact that we covered this today and then we will introduce it right away at the beginning of class tomorrow, you'll practice on it, you will learn it better as opposed to us just doing it all in one day. Do you see what I'm saying? When you have to revisit something. So try to finish up as much of the standard form as you can and then come back ready tomorrow to work on the vertex piece, and hopefully you can get a lot of that work done. But we will revisit this and help you out, and it will try to then stay in your brain for a long period of time.
Until the test works.
No. When it comes time for tests, it won't be part of your immediate recall, but when you get to the study guide, you'll then dig to your long-term recall, and it will come back. Trust me. It will come back.
It will come back for us. Or I will be free study guide. Just feel like I will kill all the dreams.